So that is the whole story about it. Let's start it off. So for us, it is useful to find the options you can eliminate, but real life, it has much more importance. So first thing is a physical quantity. We did discuss this in vectors. So what is a physical quantity? It's any quantity that can be observed and measured in an experiment. Like example, speed you can measure, energy you can measure. You can't measure fear. Getting it? It is like a snake is chasing you, a dog is chasing you. Both are scary. But can you tell me by what factor the snake is more scary than the dog? You can't say, right? Snake is 2.3 times more scary than a dog chasing you. Right? You broke something in the house, your mom is coming to beat you. Your dad is angry on you. So by what factor is mom angry on you compared to the dad? Both are angry. That much we know. Technically, both will beat you right and left, but we can't compare the factor. Right? So that way. So we will not be studying such kind of quantities. Now you can classify these quantities into three types. In vectors, we classified them in the form of scalars, vectors, and tensors. So here we have a different kind of classification. The first one are fundamental quantities. So people said, we need to define few quantities which can explain everything that we know. So we call them fundamental quantities, meaning if you know this thing, you can describe every other property for every other quantity. So the main condition for fundamental quantities are these should be non-related quantities. Which are used to describe other quantities. Example, the most common things we take are mass, length, and time. If you see, there's no relation between them. Another one, if you take force, velocity, density. So even these are non-related quantities. Exactly what do you mean non-related quantities? You should not be able to find a relation between them. Let me give another example for that. For example, if you take force, and if you take mass, and if you take acceleration. Now, if you see, we know F is equal to ma. There is a relation between them. So you should not be able to frame a relation like this. Can you frame a relation between mass, length, and time? Like mass is length by time, mass is length square by time. You can't do anything like that. Energy, mass, velocity. Energy is half mv squared. There's a relation between them. So these are related quantities. So if you can create a relation between the three quantities, you cannot use them as fundamental quantities. Therefore, force, mass, acceleration cannot be fundamental quantities. You cannot use these three to describe everything. So then people sat down and said, let's all finalize on something common, because some guy says we want kg, some guy says we want pound. So people end of the day, they sat down and said, let's fix up something we have common. So they decided, or they figured out we needed 7 fundamental quantities actually. We have chosen 7 fundamental quantities. So if you know this 7, you can explain most of the stuff. So the first one, so here we'll give you the quantity. So the units of that quantity. and dimensions of the quantity. So the first one is mass. So the property is the mass. The SI unit is kg. The dimensions is capital M. So when you see something in terms of M, we know you're talking about something related to mass. The second one is length. The units are meters. The dimensions are L. So if you say a property is L square, you're talking something based on two lengths or area or something like that. Time, we use seconds. Dimensions are capital T. Then we have temperature. We use Kelvin. This we use K. T already used for temperature, so temp. Then we have current. We use ampere. Some people use I, we can use A. Then we have amount of substance. We are talking about mole. This is MOL. Luminous intensity. This is about the brightness of light. We use something called candela. So if you look at these quantities, the first three, right, these are mostly mechanics related. So initially people thought you can define everything with these three. Then people got stuck when this thing related to thermodynamics. So you can't explain temperature with mass, length, and time. And this is electromagnetism. You can't explain charges, electric fields, and electric forces with mass, length, and time. So we needed a new one. So we had to bring current into picture. And this is for chemistry. When you want number of moles and all, you can't explain with MLT again. This is used in optics. Candela we don't have in 11th and 12th. We don't touch that normally. But remaining all we do use. The first six things we use. So that is the physical significance in the depending chapters. Have a look at this. Then people realized after the seven also there are still we need two more quantities to figure out. We call them supplementary quantities. Clear? Can I go ahead? Let's see. Then people said, still we needed two more things, supplementary quantities. The first one is a plane angle. This we did in trigonometry. So this is theta. This is your arc length. And this is the radius. So we can see theta is S by R. This is it has a units. Units are radians. But it is dimensionless. Because it's a ratio of length by length, it doesn't have a dimension. So this, they can ask in CT kind of questions. Can you have a quantity with units but no dimensions? Angle is the best one. The second one is a plane angle or solid angle. The solid angle we don't have in 11th and 12th. We don't use it, but we are going to use a variation of it. The solid angle is, this symbol is theta. This symbol is like this. We call it the units as steradian. We'll see what it means. So if you have an area like this, no, I didn't draw it properly. So this is like a two-dimensional angle. The green one is your steradian. So we define the steradian angle is that surface area, the shaded one, by r square. This surface area of the shaded part. Don't worry too much about it. We will see that later on electrostatics, then we are going to use it. For now, it is fine. The units for this thing are steradians. This is also dimensionless. So there. So finally, we stuck with 7 fundamental and 2 supplementary quantities. With this 9, you can explain everything so far what we know. Tomorrow, if something new thing comes from alien and we're not able to explain, we'll create a new unit. Clear. Next thing. Go ahead. Puroja, Arnav, Niharika, clear? Going ahead. Next one. Derived quantities. You can classify all these things into 3 types: fundamental, supplementary, and derived quantities. So these are the quantities that can be, expressed in terms of fundamental quantities. Example: force, energy, power, etc. Now, few things have to be careful here. Angles and exponents don't have dimensions. Example: if you say sine of ax, now if you see this quantity sine of ax, this is an angle. That means this ax is dimensionless. So a into x should be a dimensionless quantity. Now, same way, if you have something like e power a, or let's say 10 power a, so this a should be dimensionless. The powers cannot have dimensions. And think of like this. You can say 10 square meters. This makes sense. You can't say 10 to the power of 2 meters. This is meaningless. Are you getting it? You can't have 10 to the power of 2 meters. That doesn't make sense. You have 10 power 2, that is 100 meters. You can have a sense. So anything that is a power, powers cannot have dimensions. So this is one thing, keep in mind. Clear? Any doubts so far? Let's see. Now, let's see some questions. Now, what will I do? I'll give you a quantity. You have to find the units and you have to find the dimensions. So let me show you one. After kinematics, you guys must be tired, so you can chill out for this week. Next week, again, we'll get back. Generally, this chapter, right, is best to do when the portion gets over. But okay. Because there are quantities like, some things you don't even know the formulas for that. So, example, see, if I ask you for speed, just look at the simplest formula you can find. Speed is nothing but distance by time. So the units will be distance के लिए meter, time के लिए second. So it is meter per second. What are the dimensions? Meter का length का dimensions are L and this is time. So we write it as this L t power minus 1. Like that is what I mean by that. Give me the units and give me the dimensions. I'll show you one more. Let's say force. The simplest formula you can think of, force is mass into acceleration. Mass is kg, acceleration is meter per second square. That is length, velocity by time. So that way. And the dimensions will be m, L power 1, t power minus 2. You're getting what I'm asking? Now you guys try this thing. Give me the dimensions of energy, power, pressure. Just finish off. No need to type. I know you guys can do this thing. Finish off. I'll give you a minute. And then you can check your answers once I show you. So energy, you have to give me the units like that only, kg, meter, second square, and all that stuff, and give me the dimensions. Yeah. Finish off. Easy stuff. Done. E is equal to mc square. अभी ना तो God है रे. Energy, keep it simple. Half mv square. So mass is kg, velocity is meter square, and velocity second square. So this is m L square t minus 2. Power is simply energy by time. This is kg meter square second cube. This is ml square t minus 3. Pressure is force by area. Force is kg meter per second square by area is again meter square. So this is kg by meter second square. So this is ml minus 1 t minus 2. Clear? Easy stuff. Let's see a few more. Gravitational constant. Now, when they ask you something like this is what I was saying. You should know the formula for this. So I'll give you the formulas. So F is equal to minus G m1 m2 by r square, where F is force, r is distance, m1 m2 are masses. So there. So if you know the formula, you can from there you can get everything whatever you want. Coefficient of viscosity. The symbol is called eta. The formula is minus 6 pi r eta v. So there are multiple formulas in that. This is one of them. Again, F is force, r is radius, v is velocity. Angular velocity. Omega is simply angle by time. This is an easy one. So let's get them. Try. You got a minute. So if they ask you something weird like, relative permittivity, relative permeability, right now you won't be able to handle all those things like magnetic field and stuff because you don't know how they're related. So they have to give you the formula right now. But once the portion gets over, you will find it quite easy. You'll be able to manage all of this. So currently these things might look a little weird, this viscosity and stuff, but don't worry too much about it. And done. Show you. Look at the first one. So this is what you do. You want G, right? So keep G here and shift everything that side. Minus F r square by m1, m2. So that is force. So force is nothing but kg mass into acceleration. So that is kg meter per second square. R square is another meter square. And mass is kg square. So you will get a meter cube by kg second square. This is one of the rare unit in mechanics, where you get a m power minus 1. M minus 1 L3 T minus 2. Have a look at this. So you do have few quantities with M negative, but mechanics mein this is one. I hope you're getting how to do this thing. Same logic here for viscosity also do the same thing. So eta would be minus F by 6 pi R V. So force is kg meter per second square. Radius is 1 by meter. Velocity is meter per second. So 1 second will cancel. 1 meter will cancel. You'll be left with kg by meter second. ml minus 1 t minus 1. Easy. This thing would be radian per second. Radian has no unit, so this is only t power minus 1. Clear, everyone? Clear, na? Jainil, Arya, Abhinav, Daksha, Ojas, Surya, Nikhil. Going ahead. Let's see few more. Gas constant. Hope you know the formula. PV is equal to nRT. Pressure, volume, moles, temperature. Resistance. Voltage. Magnetic field B. F is equal to ILB. Force, current, length. Let's get them all. What is the gas constant? So R is equal to PV by NT. So P is pressure. Pressure is force by area. So kg. Meter per second square. Area is meter square. Volume is meter cube. N is mole and T is Kelvin. So this guy goes off. You end up with kg meter square by second square mole Kelvin. So this will be ml square T minus 2 mole inverse Kelvin inverse. It has 5 dimensions. It has mole, Kelvin, everything. So these are the kind of things. It's not always, it will be always in terms of MLT. Resistance. Now for resistance, what formula will you use? If we say V is equal to IR, then do you know V curve dimensions? So pick the most easiest one. Something which is related to mechanics. Do you guys remember this? Power is I square R. Now you know power na, and you know current. So from there you find out. Same thing, voltage का भी क्या कर सकते हो? Power is V square by V into I. Remember these things you studied in school. Power is I V into I and I square R. Use that. So basic the thing is what, no matter what I give you, always try to get a formula in terms of mechanics. Like I said, you don't know most of the formulas right now, but ठीक है. Try, finish up, I'll give you a minute more. Get the resistance, voltage and magnetic field. So what is this guy? So resistance is power by I square. So power is kg meter square by second cube, and this is ampere square. ml square T minus 2 A minus 2. Voltage is again same thing, power by I. Second cube now. That is second cube. Clear? What about the magnetic field? B is equal to F by IL. Kg meter per second square ampere meter. There, easy stuff. This thing so you can handle now. So if I give you something weird like this, resistance, magnetic field and all, I need to give you the formula at least now. After the portion gets over, you won't need it. But you know how to do now. So these are pretty basic stuff, like these things, like mostly CET level questions. Next one. All got this? Next thing, alternate fundamental quantities. So what if every time you don't want to take mass length time, but someone decides to take some other quantities? Like I said, there is no guarantee should take mass length time. We have just taken them because they're one of the fundamental blocks, but let's say someone decides you want to take something more complex. Let me show you with an example. That's the best thing. So let force, mass, and velocity be the fundamental quantities. Now that means now everything else will become derived quantities. So, and let's find dimensions of time. So you want to find dimensions of time using FMV. So idea is this. So you're saying this quantity time will depend on proportional to f power some x, m power y, and v power z. So if you can find x, y, z, my job's done. Something similar like that. M square, m l square t minus 2. So m ka place mein f is there, l ka place mein m is there, and t ka place mein y is there. So this is how we do this thing. So on the left hand side, we have m power 0, l power 0, t power 1. On the right side, the force is nothing but mlt minus 2 to the power of x. Mass is mass only. Velocity is lt minus 1 to the power of z. So bring all m's together. So this will be mx plus y, L will be x plus z, and t will be minus 2x minus z. So in the LHS, you have m ka power 1. So exponents should be same. So exponents of the respective quantities must be same. Because you can't equate mass with length and length with time. So mass ka power should be same. So you can clearly see here x plus y is 0, x plus z is 0, minus 2x minus z is equal to 1. So from here we get x is equal to minus z. Take this and substitute here. So this would be z is equal to 1. X is equal to minus 1. And this is y is equal to minus x. The y is also equal to 1. So that means time is proportional to the dimensions will be f power minus 1, m power 1, and v power 1. F minus 1, m1, v1. Is this making sense? So just like MLT, you're getting FMV. Have a look at this. So endurance and dimensions, right? This is one decent type of questions. Among the questions that you have, this is one a decent one. So we really don't have too many interesting models, like 3, 4, and this is one of them. Clear with this? So let's see something similar now. You guys give it a try. Any doubts on this page, please ask me. Let's see. If force, density, and velocity are taken as fundamental quantities, find dimensions of pressure and mass. 2 questions. Get them. Anyone not clear with anything, please ask. Clear, please go ahead. Idea is the same. You have to do like this. So you will say pressure is proportional to F power X, rho power Y, and V power Z, and then you know what to do. Give it a try. Any answers for this? Show you. Let's see. F0D1V square. Yeah, that looks right. 0, 1, 2. So let's see the first one. The pressure is proportional to F power X, density power Y, V power Z. So pressure is a force by area. So that would be M power 1, L minus 1, T minus 2. So this guy would be mLT minus 2 to the power of X. Density is mass by volume, so ml minus 3. Velocity is the distance by the time, so z. Bring all m's together, x plus y. L would be x minus 3y plus z. T will be minus 2x minus z. Yeah, it's brute force solving. There's nothing there to think too much. So we have x plus y is equal to 1. Then we have x minus 3y plus z is equal to 1 minus 1. Minus 2x minus z is equal to minus 2. So normally when you get like this, what I do, I will see which variable can I replace. So y is 1 minus x, I'll dump it in this. Z is 2 minus 2x, I'll dump it in this. So I'm basically eliminating x from, I'm getting everything in terms of x. So this is x minus 3 into 1 minus x plus 2 minus 2x is equal to minus 1. This would be x minus 3. You get x is equal to 0. Z is equal to 2 and y is equal to 1. There. So pressure is proportional to F power 0, doesn't depend on this, rho power 1 and V power 2. Easy? Same thing. Can you do for the mass? Looks like most of you got such a weird answers, right? We have 1 by 3, 2 by 3, 16 by 3. That looks weird.
Sir, I got a calculation mistake.
Yeah, check karo. Daksha, I'm not sure about the answer. Let's see, anyone else got it? Try for the mass, I'll give you a minute more. It is the same. I don't think you'll get such good numbers though. You will get 1 by 3, something like that, but integers nahi aayega. Try.
So the first one actually I had sent for pressure. So
Come in.
I've sent just now, that's for the mass.
Let's see. I'll show. We'll check it out. Others also try. 3/2 minus half b minus 3, Shana. That could be right. देखना पड़ेगा. Let's say I don't remember. Yeah, I think both of you got the same. Niharika, Shana. F power 3/2, d power minus half, v power minus 3. We have two answers. Let's see. I think, yeah, and she also got the same. Nikhil, yeah, I think most of you got that thing. So this is mass m. So m power 1, L power 0, T power 0. The RHS will be the same. So x plus y is 1. X minus 3y plus z is 0. Minus 2x minus z is 0. So z is minus 2x. Y is 1 minus x. So dump it here and dump it here. X minus 3 into 1 minus x. So normally when you have three equations, do that. Get, just focus on one variable. Then this would be minus 2x is equal to 0. This would be 4 minus 2, 3/2. X आ गया तो z is minus 3. Y would be minus half. There. So m is proportional to f power 3/2, rho power minus half, and v power minus 3. Make sense? Easy? Yeah. Next one. So how do we use this dimensional analysis? It does have its uses. It's especially when you're doing an experiment and you're trying to figure out relation between stuff. This thing at least gives you some important things, gives you some ideas on how the equation should look like. So dimension analysis is useful to check the correctness of the equation. We call this thing principle of homogeneity. What this thing says is, only similar quantities can be added, subtracted, or compared. Since you can't add energy to velocity. You can't compare power to force. Example, if you say the quantity energy is given by A plus B into C square, you can be sure the quantity A and B square both are energy, should be in energy terms. So A must be energy and B C square should be energy. Same thing, if you see S is ut plus half at square. So here also, if you see, this thing has a dimensions. of L. This also should have dimensions of L. UT. This also should have dimensions of L. All should have dimensions of L. But there is a problem with this thing. The drawback. Now, if an equation is dimensionally correct, no, so that equation is dimensionally wrong, it is definitely wrong. But if it's dimensionally correct, there is no guarantee it is right. The problem is you cannot find the constants ka dimensions. If the dimensions don't match, the equation is wrong. And if dimensions match, we are not sure whether it is right. So it can only tell whether something is wrong. It can't tell whether you're right or wrong, whether you're right. That's what I said. When you see the options, right, if some dimensions don't match, you can say it is wrong. If dimensions match, you can't figure out whether it is right. Example, the same equation, if I write S is equal to UT plus 100 AT square. Now, if you look at this equation is definitely wrong, but dimensions match. Have a look at this. Let's see. Let's see a question. So let's say we have U is equal to A square by 2mr square minus bm square by r. So this quantity U is potential energy, m is mass, r is distance. So find the dimensions of A and B. Last one is m. I don't think it is m. M square L power 4 t minus 2 m minus 1 L 3 t minus 2. Could be. Try. I'll give 1 more minute, everyone. Then I'll show you. Let's see. See, the idea here is, so this U is energy. So this whole thing also must be energy. And this whole thing also must be energy. So we can say A square by 2mr square is proportional to energy. So you can simply say A is proportional to energy mr square ka root. We know energy ka dimensions are m L square t minus 2, mass is m, and that is L square. So when m comes out, L square comes out, and t minus 1. That is A. Check it out. Maybe you guys forgot a square root, I guess. That is A square there in the formula. Similarly, Bm square by R is also proportional to energy. So this is energy into distance by mass square. So energy is ml square t minus 2. This is length, and this is m square. M minus 2 L cube t minus 2. Right?
So it be m minus 1, right?
Yes.
M minus 1. You're right. All got this? Easy? Let's see one more. Any doubts on this? Please ask me. Clear na? Arnav, Daksha, Jainil, Surya, Niharika, clear this? Next one. V is root over A lambda by 2 pi plus 2 pi b by rho lambda. Lambda is wavelength, rho is density, b is velocity. Find dimensions of A and B. Let's see. The square is on both sides. We get v square is a lambda by 2 pi plus 2p by rho lambda. So basically this and this guy has a dimension of speed square. So a lambda by 2 pi is proportional to v square. So lambda would be v square. A will be v square by lambda. So the dimensions would be L square t minus 2 by L. Lt minus 2, right? What m क्या m आएगा नहीं आएगा. Next thing, same thing, 2 pi b by rho lambda is also v square. So b is proportional to rho lambda v square. That is density, which is mass by volume, ml minus 3, and this is the length, and this is L square t minus 2. mt minus 2. L नहीं आया रे. Or did I mess up somewhere? Right? Yeah, you got it, Niharika. Others? Clear with this? Easy one. Let's see one more. This is the second type of questions. They will give you some quantity, they'll ask you dimensions. Let's see one more. So pressure P is given by A by B e to the power of minus Ct plus C into D sine Bx. Here T is time, X is position. Find dimensions of ABCD. B L minus 1, C T minus 1. Yeah, that looks like it. Let's see. One more minute. Remember, I told you something, the dimensions of the power. So CET should be dimensionless, BX should be dimensionless. That would give you the C and B dimensions. Because E to the power of something should be a dimensionless quantity. So this guy here and this guy here should be dimensionless. So BX must have no dimension. So basically B must be, dimensions of B is L minus 1. Similarly, this is also dimensionless. So you can clearly see dimensions of C should be time T power minus 1. Now this quantity must be pressure, because you can add only pressure. This CD also must be pressure. So you can relate like this. So this A by B is proportional to pressure. So dimensions of A would be, pressure ka dimensions are what? Force by area, ML minus 1, T minus 2, and B is again L minus 1. That's right, ML minus 1, T minus 2. Yeah. And then CD also must be pressure. So D ka dimensions will be ML minus 1, T minus 2, D ka dimensions are T minus 1. So ML minus 1, T minus 1. Clear? Easy stuff. Hope you're getting it. So you saw the chapter of it. It's not tough, but yeah, it is little different. You should know the stuff how to do and all. Did everyone solve the paper? This time paper was little tough. There are a few questions which are little tough. Okay, so with this, we'll wrap up for the day. We will discuss the paper today. I think that will take time. There are some good questions also in that. I'm sure if you have solved it, you would realize. So next class, when we catch up here, we're going to do more. We will do a few more things on dimension analysis, and then we'll do something called significant figures. So the main thing starts from there. All this thing what we do today is like